So let's continue, guys. Now let's make a geometry. Let's get inside. Let's make a planar patch. Let's make it dx like this. Let's reduce this number, maybe like that. Okay. Then let's add a Vellum configure cloth and Vellum solver. Okay. Of course, if we hit play, it will fall down. That's not what we want. We want to talk a little about the pin to animation. We understand from the previous lesson, pin to animation, when we pin any point like this, it will pin this point, so basically those will be freeze on its place. So those place, as we can see, it's not going to fall. And also, if we have an animation, for example, let's make a transform like this. Let's make here a rotate, for example. This one will rotate. Yeah, we can make it something like f multiplied by 0.1, and we hit match to animation. It will follow its animation, as we can see here, right? This is moving, but it is slowly. So basically, this is pyramid, as we know. Pyramid just mean this pin, it will stay the same. It's not going to change. It's not going to unpin. Okay, nothing really is going to happen to it. Just permanent. Okay. But what if we want this pin to disconnect or disable in after many frames? So we have also two types. We have stopped and we have soft. To know the difference, first we need to get inside the spreadsheet. Let's hide all. Okay, so if we make a stop, let's see what's going to happen. Now we have a new attribute called stopped. So basically, stopped, if we check here, we have stopped 0 and 1. 1, it's the point that we choose here, right? If we choose its number, as we can see here, 6, 4, 5. As we can see here, 6, 4, 5. Yeah, it's 1. So all these numbers that's here are 1. So basically, stopped, give it 0, and if any of this point is pinned, we choose it, then it will give it 1. Okay, so yeah, I'm sorry. So when we want to any points will unpin later, we will give it a value of 0. Okay, this is first. And of course, to do something like this, we will did it inside here, inside the Vellum solver. But before we do this, let's continue. Let's see what else do we have here. If we add match to animation, I don't see anything here, but I think we have a glue to animation. Let's choose it. If we uncheck it, as we can see, glue to animation will disappear. So basically, glue to animation, same thing as the stopped, but it inherit the position, the original position of every point. Okay, as we can see here. So it will follow any animation that we have here, same as transform. We have orientation, so it's inherited by match animation by this glue to animation. Okay, so we both can control it inside here. For example, Okay, we will take a sample for it, but a little later. Okay. Next we have soft. What the difference between the stopped and the soft? Basically, as I said, soft, as I or I will say now, stopped is like glue, or like linear, or like 0 on 1. It's only pin or unpin. It's break or unbreak. Okay, but soft, it's more like a string. If we check here, but of course this string we might need to, since it's a string, so we might need to, I will copy all this, Control A, Control X, make this parent, nothing here. Let's make another Vellum constraint. Let's put it here. Let's choose pin to target, and also let's choose soft match. As we can see here now, it's give every point, it consider every point is a pin, as we can see here. So we have to choose which point do we want to make it as a pin. So we'll choose maybe this only, hit enter. So as we can see here now, we have something like this. So if we increase now the stiffness and hit play, yeah, well, I think there's something wrong here. Oh yeah, I'm sorry, because I'm open, I stand here, I should stand there. Okay, yeah, so basically this is only, and if we see the string, we have a string here. I'm not sure why it's not. Let's try to see it, pin to string. Yeah, as we can see here now, we can see the string clearly. It's string up and down. Actually depend on the stiffness that we choose here, and of course we can control it. We can even give it a name like for example a pin underscore stretch. So we will have a new group only for this point that called pen stretch, that we can control it inside here in the Vellum solver as Vellum. Let's say Vellum constraint properties. Let's add it here, let's add it there, let's choose this, let's choose yeah, we have to start from the beginning. Pin to stretch, we can control its remove, we can control its stiffness, we can control lots and lots of things. Maybe I will simply just say, maybe after control $F is bigger than 20. So after 20 frame it will remove or cut this string. Okay, I hit play, as you can see, then it cut, right? So we can control it from its group called pin stretch. We can also see the group here, as we can see. I think it's in the constraint. Yes, it's pin stretch. Okay, it has many features. Even also it has its own system. I think break. It has its own break. Even in such a threshold, it will cut by its own. So even we don't have to choose this, to use this one. If we check the break, if the threshold, if it crosses this threshold, it will cut. Yeah, as we can see here, some of them are cut it. Let's increase this number a little more. So it depends on the stretch stretch. It has also stretch distance, stretch ratio. Let's check again. Okay, let's say 1. Yeah, okay, it's not really. Let's do it like this. Reduce the number. Yeah, so basically, when we have a small number, it will disconnect as we see here. Okay, so this is also one of its feature. So let's also take another example. I will say another planner patch 0.5, and then let's make a Vellum configure class, and also let's make a Vellum solver as we can see here. Okay, let's make some pin. If we choose some pin here, hit enter. Now we have pin permanent. Let's check something. If we check the mass, we'll find that the pin that we choose has a mass of 0. That means any pin, it reduce the number of the mass, or the value of the mass, to 0, as we can see here. Of course, we can check its number here, like 237. 237, yeah, here is a 237, 238. All of them have 0. So basically, pin also change the mass. One of the things that we should know. So basically, if we want to, we can even not using this pin, but simply use change the parameter of the mass. Of course, mass is in the geometry, the Vellum geometry, as you can see here. So maybe we can do both. We can draw it here or draw it there. I will draw it there. Let's use attribute paint for now, and simply I will choose 0, and I will type here mass. Let's make sure that everything here yeah, it's drawing, but I don't know why it didn't appear here. But anyway, yeah, I think it's yeah, because it's 0. I think that's why. But anyway, as we can see here, we can, for example, I will delete one, I will add another one, attribute paint. And I will, of course, I have to make it 0, because any pin has a 0 mass, or any mass 0, it give us it consider it as a pin. The point that has a value of 0, it will consider it as a pin. So let's, for example, something like this across. So let's check what we have here. Yeah, as we can see here, we have a cross. And I think, yeah, but I think we should, if we need a glue to animation, yeah, we don't have it will just only add match animation. If we have animation here, which we don't have animation, but we can add animation like this, and just make it f multiply by 0.5. So let's see what we have here so far. I think we should show animation, rotate, okay. Yeah, but I'm not sure if it's okay. Let's add this one. Yeah, so I think basically match to animation, it will happen if we still add a real point, not just this one. So if we make this one like this, F2, let's just add those like this, maybe hit enter. Now we have them here. Let's see what we have here so far. Yeah, so basically to have a match animation, still we need to choose the points. Interesting, didn't know this information, but anyway, at least now we know that to control the pin, change the mass to become. So now let's collect all this together. Let's make a test, maybe this one, and maybe I'll make it slower just to, yeah, okay, looks good. This one. Okay, next, I think I don't need a shader for now. I will remesh it. Make it 0.5, maybe more. 0.3. Yeah, maybe something like this. Okay, maybe 0.2 or something. Okay, we don't need this now. Next, let's add fracture edge or edge fracture, and this one is very cool. We can add fracture, but in the edge itself, it doesn't cut it like Voronoi fracture. Voronoi usually cut it in the half, thing like that, but edge fracture, it's only cut it in the edge itself. Okay, of course we can add more, like 100. Why not? Actually 100 is, maybe we can add 200, 500. Maybe I will add it 1000. Actually 1000 looks better. Next, let's add a transform, and this transform, it will move in this direction.